to take your seat.
All right. Yes. Hello. Good morning. Good morning. My name is Clara Castellanos Lopez. Right now I work at Expedia Group. I'm part of the content team, and today I'm going to talk to you about how we're using ML to improve the property content that we're displaying to our travelers. I have a PhD in computational geophysics, a master's in math, and I've been at Expedia Group for around a year. So what I'm going to walk you through today is I'm going to give a little bit of an introduction to Expedia Group, the business, and then I'm going to talk about the business opportunity and basically how ML fits into it. And then I'm going to walk you through 3 of our models that are live today powered by ML. And I'm going to end with some future opportunities and what we're looking to do there. So a little bit about Expedia Group. So our logo is Power Global Travel for Everyone, Everywhere. And we are really aiming to do that. So it is, Expedia Group is an interesting business because it's a two-sided marketplace. On one hand, you have the travelers looking for the properties, and on the other hand, you have the partners offering their services. What I'm going to talk about today is mainly on the traveler side, but there are lots of equally interesting problems on the partner side. Expedia Group has several relevant brands. Expedia is one of them, but we also have Hotels.com and Vrbo for vacation rentals. And we have a lot of offerings, so hotels, vacation rentals, but we also have other things that we're probably less known for. But we also have airlines, activities, car rentals, so on. There are over 3 million properties, over 200,000 activities, so it's large. Our offerings are large. And because of this, Expedia Group has been using ML to power data-driven decisions and to make all of these processes scalable. So we already have a lot of content, but this content is actually increasing every day. So to be able to ingest it and to show travelers the most relevant content, we have to use, ML. But in choosing these models, we have to meet several requirements. So the first one is these models that we're going to build, they have to be scalable. So we have to process, but actually we have to reprocess images, millions of images, text, and so on, every day. Because every day we're getting new properties or new images or new reviews coming in. So we have to update our models quite frequently. So these models have to be scalable. Second, as we said, as we want to power travel for everyone, everywhere, we have to think as a global business. And I'm sure, as in any other e-business, you can see the value of reaching the global market. And to do that, we need multilingual solutions and localized solutions. So I'm going to touch upon this later on. And finally, we need models that can be tailored for each of our brands. So as I said, we have vacation rentals with Vrbo, and we also have Hotels.com. So these models have subtleties, differences in what we want to show to customers. There are different type of customer segments, so we have to be able to tailor it for those. And for finally, to be able to actually know which ML model is better and to be able to test, you need a really good A/B testing infrastructure. And we also benefit from having a really good multi-arm bandit infrastructure that allows us to, explore other options. And again, I'm going to touch upon this when I walk through the models. So I'm going to talk about 3 of the models that we have in content today in production. So everything I'm going to show you today are things that you can go on the website and you're going to have the experience benefiting from these models. Now, what I'm not going to talk about is, Expedia Group has a lot of problems, and the most common one is probably ranking properties when you go and search for a hotel, for example. So I'm not going to talk about that. I'm only going to talk about, basically everything that's concerned, that concerns displaying content related to properties themselves. So that's a little bit of the setting. So let's go on to the first one. So images are the first impression you get of an item, probably the most important first impression you have of a property once you go in to look for it. So you're maybe looking for properties, but you're also comparing across properties. And images play a key role. They have to have the right balance between aesthetically pleasing and relevancy. So we have thousands of images, millions of images, actually, across our brands. And we have two kind of questions we have to answer. So the first one is, what is going to be the image that we show when we're offering you the several properties, the listing of properties? And that's called the hero image. So we have to pick a single image for each property that kind of encapsulates the essence of the property and for your search criteria, right? And we have to solve that problem first. Next, once you click on the property, you're going to go onto, the property page where you get a lot of information. But one of the things that you will see are actually all the other images related to that property. And this is called the image gallery. These set of images, we also have to rank them. So basically select and sort which images we're going to show to you. So how do we do this? So let's focus on I'm going to focus on the hero image ranking problem. So this is basically a two-step process. So the first step is a traditional supervised model, computer vision model. We train a computer vision model to basically, using traveler feedback from our website, we train a computer vision model that will predict or score the relevancy of each image. And after we have this ranking model, we score all of the images. This, of course, gives us the hero image, but also the sorting for the image gallery. Now, these supervised computer vision approaches, they work very well. They generalize very well. So what I mean by generalize is, if you take in a new property or a new image, you can pass it through the model that we've trained, and it will perform really well. On the downside, the problem is that it's a very static kind of view, and it allows for very little exploration. Like, the question is there another image, or is there the possibility that there was another image that would have been a more relevant hero image? And to answer this question is when we are able to use our multi-armed bandit infrastructure. So think of multi-armed bandit as a kind of A/B testing, but with multiple arms. And it has also the crucial difference that it allows to focus traffic on the most relevant arms and divert traffic away from the least relevant arms. So for the multi-armed bandit, the goal is to find the best image possible while minimizing the exposure to the least relevant. So basically, that is minimizing the regret, right? Because this is something we're testing live to customers. So you don't want, if you're showing an image of less quality or less relevant, you don't want that to go and stay there being shown to customers for a very long time. So this is the optimization process that the multi-armed bandit is solving. And because I'm talking about the best image, we have to define what the best image is. And in this context, it's the image that's getting, the image with the highest click-through rate, the image that's getting the highest number of clicks. And so like I said, the whole optimization process here is minimizing the regret, minimizing exposure to the low quality images. So basically, the algorithm is as follows. We use the traditional supervised computer vision ranking model that it's trained based on customer feedback. We take the top K images, and now we're allowed to explore, basically, with the multi-arm bandit. We talk with the top K images, we put them all, and we start exploring with our real life customers. To choose the top K images, though, we don't actually choose the top K because we impose some diversity between categories. So basically, you don't want to explore which is the best pool image to show. We want to explore like a little bit of pool images and beach images or property front images. This is the type of diversity that we're trying to, or like exploration that we're trying to encourage with the multi-arm bandit campaign. So once we do this, we select the top K images. Now we have to balance this trade-off between exploration and exploitation. So that is actually done through Thomson sampling, where basically the click-through rates are given basically the distribution, and you're sampling more those images that are giving the highest, getting the highest click-through rate, and you're less likely to sample those images that have the lowest click-through rate, and thus that is how eventually there is a convergence to a hero image. And that is how finally selected. So this, for example, these are on the right. These are the images that you would see as highest ranked images, or images you're highly likely to see on our website. On the left are the images that are, have the lowest ranking scores, images that are least likely to see. And this, this process and the two-step process for the hero image, we've A/B tested it. So after the multi-arm bandit, we go back to A/B testing it. And this has actually, we've measured positive customer feedback, positive improvement in our metrics, in our business metrics. If you are interested in learning more, there's actually a really good blog in Medium. I'll link it at the end. The last thing I should probably say about the hero image is that, as we're doing the multi-arm bandit, every customer does see the same, hero image throughout the session. We're not. If you come back for another session, it's likely you'll see another one, but throughout the session, we do have consistency. Okay, moving on to another type of problem, which is the transliteration problem. So transliteration is not a problem known to people outside localization teams, but translation is. So translation, everybody knows. Translation is the problem of, you want to present your content in the right language to the, to the local market. Transliteration is a little bit different because it's only for some markets that want this type of product. So transliteration is, we want to translate not the meaning, but the sound of words or a sentence, or in this case, property names. So basically, this is an example of a Japanese property website, and we have the name Baglioni Hotel London. So we don't want to translate the name. We don't want to say, how would you say hotel in Japanese? That's not what we're looking to do. What we want is, with Baglioni Hotel London, we want to write it in Japanese characters such that when someone reads this, I don't know if there are any Japanese speakers in the room, but if someone reads this, it should sound Baglioni Hotel London. So basically, it's giving the ability to travelers in a local market to read in their own language the name of the hotel, such that it sounds as if it were from the source, like the English in this case. So this, like I said, it's not for all markets. We have some markets that require this, like Japan, Thailand, and it's always shown in our property pages just above the name of the hotel. So Expedia has been doing this for a long time, and this has been a manual process. So we have localization teams for each language, for each market that requires this, doing this. So obviously, because it's a manual process, there was an opportunity to automate this with ML. And transliteration is, although it's not a widely known problem, it's a very well-known problem for global, market businesses. And so there are, many models that have addressed this problem. It's basically a sequence-to-sequence model. And one of the models that was available, for example, is one from a Google paper. So we tested this Google paper, this model from the Google paper. We tested it on our property names, and unfortunately, the character error rates were really high. It was, ranging from 23 to 45%, depending on the language. So obviously, this is not good for production. But fortunately, we did have a lot of data, a lot of property names that have been transliterated in several languages by our in-house localization team. So we fine-tuned these models, and we got a really good result of showing errors less than 7%. Some of these languages, it drops down to even 3%. So we trained on our in-house data. We also added extra intelligence, I would say, to it, because we do know where the property is located. So we know that if a property is located in London and it has the word grand, or if a property is located in France and has the word grand, the transliteration, grand and grand, it would be very different for when we're doing the transliteration model. So we've seen success, and again, you can see this live on our website, powered by ML. And 5 minutes, yeah, I'm almost finished. And finally, we have the room recommendations. So you've done choosing a property, and now you have to book a room. And it turns out that there are many rooms, so typically 5+ rooms, but you don't only have to choose a room, you also have to choose, do you want free cancellation and free Wi-Fi and free breakfast, or do you want free cancellation and only free cancellation, or any combination of those? So there are more than 10 combinations. And typically what we were doing is showing all the rooms and all the possible combinations of add-ons from a lowest price to the highest price. And so travelers would have to traverse just the website and trying to find which is the one that is best suits their needs. And we saw that more than 40% of travelers don't book the cheapest one. So that means 40% of travelers don't book the first one that's there, but that are actually doing the job of going there. So again, how can we make this easier for our travelers and make it easier to find what it is that they're looking for? What is the most likely room and add-on that you're most likely to predict or to book? So this is, again, a ranking problem. So we took customer data, clickstream data from our website, everyone that booked a room. So the training data is everyone that did book a room with all the things that we know about the context, not personalized, but just of the search criteria, like how long you're going to stay, where you're going to stay, how many people are traveling, everything that we know about the search criteria. Of the people that booked a room, what were the combinations with that room, like free Wi-Fi, free cancellation, so on. So there are things that you would typically expect, like the longer the time window for the booking is, the more likely is that you're likely to book something with free cancellation. So we took all that data, and again, we did a ranking, list-wise ranking model, and the option that's more likely for you to book is now presented on the website as a first option, and it's shown with a banner. So now we show the output of the model, the predicted room, is shown on the first position, and the rest, they're ordered as they were before. So from lowest to increasing price. But the first one is the one that the model is predicting, and it has a banner on the top explaining why we think you're likely to book this room. And sure enough, we tested this. We A/B tested this, and again, we've seen positive results from it. So where are we going next? So all these models are, the last one that we saw is already including contextual, some contextual information. But as we grow and as we want to provide a better traveler experience, what we believe at Expedia Group is that the opportunity here is around contextualization and personalization. So yes, we want to show relevant content, but we want to show relevant content for you and depending where you are on the traveler journey. Like, have you come in to book a flight for the first time? Is it like, are you exploring, or have you already been here 5 times and you're already like in the nitty-gritty of the details of finding which is the best price? So of the models that I've shown, for example, you can think that for the image ranking, for the hero image especially, we could try and make that contextual, depending on what we think, what we know of your search. So at the moment, it's not contextual. So everyone in the same arm of the bandit will receive the same treatment. But that's something we're starting to think about. Contextual amenity ranking as well. Some people are more interested to know, is there super fast Wi-Fi if you're like on a business travel? Some people are interested in, is there a playground around there? And we've been doing generation, NLG, natural language generation, for some things like descriptions, property descriptions. And how to make these generations contextual is also something we're still working on, but that we do believe could unlock a lot of benefits. And same for image captions. So the key takeaway, I would say, we've done, the work I've presented here is the work of the whole content team. And there's been a lot of work and a lot of learnings as well. I think to improve the ones that we've seen, the models that we see that have tested positive with travelers, we know that it's because we're improving the traveler experience and making it easier for travelers to understand the property, make it easier for travelers to choose a property. And you need really good testing infrastructure. Multi-arm bandit has helped a lot, and a really good A/B testing. Otherwise, it's going to be difficult to know which model is performing better than which. Finally, to be truly global business, as I'm sure most of you are, you need good localization strategies, and ML has a really big role to play here, because a lot of these tasks are done by people, and so there's an automation opportunity. Training, fine-tuning on your data set. We saw it with the transliteration model here today. It proves to be beneficial. And finally, like I mentioned, making all of them contextual is, I think, the next challenge. And that's it.